Now we'll be talking about piecewise functions. So piecewise functions, they're functions that are defined over certain parts of the domain. So they'll look kind of disjoint pretty often, like they'll kind of change directions. So looking at number 3, we've got f of x equals 3x minus 1 if x is less than 0. And f of x equals negative 2x plus 3 if x is greater than or equal to 0. So when we're evaluating these functions, first what we have to look at is what's our x value and which part of the domain is that x value in. So if we look at f of negative 2, we've got two choices, either x is less than 0 or x is greater than or equal to 0. And if x equals negative 2, then it's true that negative 2 is less than 0, right? So for f of negative 2, we're going to be using 3x minus 1 because that's the portion of the domain where negative 2 is in, right? Negative 2 is less than 0. That's the portion of the domain that negative 2 is in, so we're using that portion of the function, that piece of the function. All right, so using the 3x minus 1, f of negative 2 equals 3 times negative 2 minus 1, which is negative 6 minus 1, for a grand total of negative 7. F of 0, 0 would be in that second part of the domain, right? It's true that 0 is greater than or equal to 0. That's a true statement. So we're using the second piece of the function. So we're going to use the f of x equals negative 2x plus 3 piece of our function. So f of 0 equals negative 2 times 0 plus 3, which equals 3. And for f of 3, it's true that 3 is greater than or equal to 0. So we're again going to use that second piece of the function. So for f of 3, this will be negative 2 times 3 plus 3, which is negative 6 plus 3, which gives me negative 3. All right, now what would a graph of a piecewise function look like? These are just examples of evaluating the function at different x values. So what would our graph look like? So for number 3, if you want, you can go to your graphing calculator, and for y1, we can put in 3x minus 1, and then use the down arrow to go to y2, and we can put in negative 2x plus 3. Just to see these two graphs. So 3x minus 1 is this blue line that we see on the screen, and then negative 2x plus 3, that's the red line that we see on the screen. So if we want to graph these on the same axis, I'll use blue for this piece of my function. Remember, this is only defined where x is less than 0. If I use my trace key at x equals 0, let's see, we would have a y value of negative 1. We can see that in the blue. So if x equals 0, y1 equals negative 1. I'm going to use an open circle. So an open circle at 0, negative 1 to denote this, because this piece of the function is only valid where x is strictly less than 0, not if x equals 0. So right at 0, negative 1, I'm going to put an open circle. That means that this point doesn't exist on the function. And then I'm going to continue down. So from this point, I'm going to go down 3 into the left 1, following the slope. So down for negative 3 to the left for negative 1. That's equivalent to a positive 3 slope. And I'm going to go to the left because this is where x is less than 0. So down 1, 2, 3 into the left 1. So this would be on our line. So that's that blue piece of our line. So it goes up until the point where x equals 0. It's not defined at x equals 0, only defined for x less than 0. And then I'll do the right-hand portion of the graph in purple. It's red on the graphing calculator. I'll use purple here. So again, at 0, I can see in red on my calculator, at 0, I have y equals 3. At 0, I have y equals 3. Now the function is defined here, so I'm going to use a closed circle at 0, 3, 1, 2, 3 to denote the fact that that point does exist for this function. And then I have my slope of -2, so continuing to find new points, I'm going to go down 2 to the right 1, down 2 to the right 1. I'll draw a few points there, and then go ahead and connect. That's the next piece of my function. So that's what my piecewise function looks like here. You can see that it would pass the vertical line test because every individual vertical line would hit my graph only once. Even if I'm drawing a vertical line where x equals 0 is, I'm only going to hit my graph here because that's a closed circle. I wouldn't hit it the open circle. That's not part of my function. All right. Now let's take a look.